Next two problems that we're going to look at, C and D, are the very same format as A and B. We want to convert to polar form and then confirm that my rectangular and polar are the same. So right here, 4x plus 11y minus 5 is equal to 0. Let's convert to polar form. And to do that, we replace all x's with r cosine theta, and we replace all y's with r sine theta. Now we can look at getting rid of those parentheses. 4r cosine theta plus 11r sine theta. And we can move our 5 to the other side. Now I can factor out an r. And then I can divide both sides by this large quantity. So r is equal to 5 divided by 4 cosine theta plus 11 sine theta. Let's confirm we get the same picture when we look at both rectangular and polar form. Right here, 4x plus 11y minus 5 is equal to 0. We know that's going to be a straight line. Let's see what our slope and y-intercept is going to be. So with this one, if we want to convert it, the first thing we would do is move the 5 and the 4x to the other side. So we get 11y is equal to negative 4x plus 5. And then we'll divide both sides by 11. So what we're saying here is r equals 5 divided by 4 cosine theta plus 11 sine theta is going to be the same thing as y equals negative 4 over 11x plus 5 elevenths. So y-intercept of 5 elevenths, a slope of negative 4 elevenths. So we can plug that into our calculator and confirm if we get that. So go back to functional mode, delete my previous problem, and really you should know what this looks like. Negative 4 elevenths x plus 5 elevenths. Straight line there, negative slope going through 5 elevenths. I convert to polar form, and I'll put in 5 divided by 4 cosine of theta plus 11 sine of theta. And you can see I get the same picture there. Now we're going to talk about restricting polar form, so that's why the line doesn't go on forever in both directions. But you can see right there I've got the negative slope of 4 elevenths and it goes through the point 5 elevenths. So I've got the same picture there. So those two are equivalent. The second one here, 5xy is equal to 1. Let's convert to polar form. So 5 r cosine theta, r sine theta is equal to 1. Divide both sides by 5 and get rid of parentheses. So r squared cosine theta, sine theta is equal to 1/5. We want to get r by itself. So r squared is equal to 1 over 5 cosine theta sine theta. And then we'll take the square root. R equals 5 plus or minus the square root of 1 over 5 cosine theta sine theta. And then we'd like to simplify as much as we can. This cosine and sine in the denominator is going to be the same thing as the secant and cosecant. There's my final answer. However, we're going to have to use this guy to plug into the calculator since we don't have the secant and cosecant buttons on our calculator. If we look at this, we're going to plug this into y equals form. So let's come over here, and we are going to write that in terms of y. So y equals 1 over 5x. And that, you know, is a rational function. So it's going to have the curves in the first and the third quadrant. If you don't remember what that looks like, let's confirm by plugging that into our calculator. So we'll go to functional mode. And we'll start by doing 1 divided by 5x. Now I want to make sure that x gets in the denominator, so I'll put that in parentheses. I really don't see that too well, so let me zoom in, and we'll do a quick zoom box. And you could just use zoom in if you're not familiar with how to use the zoom box feature. But I want to zoom in just to that small area. And sure enough, there's my rational function graph that you've seen before. So I got a curve in the first quadrant and a curve in the third quadrant. Let me convert this to polar form, and we want to make sure we get the same equation, same graph. So the square root of 1 divided by 5 cosine theta sine of theta, and then the other one, negative square root of 1 divided by 5 cosine theta sine theta. And sure enough, when I graph it, I can see I got the curves in the first and the third quadrant. Now, do I need both of these once again? Well, let's turn off one of them. If I turn off R1 and just graph R2, I can see from the third quadrant I'm going down, and then I graph the first one going up. If I turn the first one on and the second one off, I'll get the same picture. It's just that they'll be drawn in the reverse order. So yes, if I look at 5xy equals 1, that is the same thing as r equals plus or minus the square root of secant theta cosecant of theta over 5.